Hey, so this is for basically, so we did the optoisolator code, right? Yeah, pin B it's working. So the pin B code is working. That's that's the pin change interrupt. So we have two more interrupts, right? The first one of the second one is it basically the 1 second count. Once we count to 1 second, we want to calculate how many optoisolator, how many times pin B switched up and down. And then basically from there we want to multiply that by 60 to get the RPM. Okay, so looking at the main code real quick, duty cycle is initially set to the percentage, which is basically a constant macro, 60 divided by 100 times 255, and then we take the int, we typecast it. RPM is initially 0, revolutions done. We're just testing code right now, so we're putting 10 right here because we're not counting the revolutions. This is just testing one part of the code, which is the timer 1. Timer 1 will counts to it's supposed to count to 1 second. LCD initialized, because what we're going to do is to test this code, we're going to display it on the LCD right here. Okay, so to test this code, this is what's going to go. So this is basically this is basically the timer counter control. Timer counter register starts at 0. It counts to 7A12, which is basically comparing it to 31250. And the prescaler, basically looking at these guys, looking at here, prescaler is 256. CTC mode. That's why we're using these guys. TIM SK1. It's going to set OCI E1A. So this basically we're using this timer, and I think it's output compare. And then from there, we just have to set SEI to 0. This is just another tester. The while code, we concatenate a string, a character array. The character array, again, is right here, LCD output string, it's of 15. And then from there, output string gets %D, we're using RPM. So it should be constantly displaying the RPM. Tester equals 10 minus tester. That was just something else. Really just, again, for testing, but I think. LCD puts is right here, displays it to the output screen. That's basically the main method. Going down here, this is basically the ISR. The ISR is basically like the vector. So we're doing a timer 1 compare, and this is the vector. RPM becomes revolutions done, which is being calculated by another interrupt, right? The optoisolator one. We multiply that by 60, and then I commented this out. Again, we're testing the code. Revolutions done equals 0, because we want to count back again up to revolutions, and then we can calculate again for the next second if there's a change. But we have this at 0 because we want to keep revolutions done up in the code. We just want to keep it at 10. So the idea is that actually what we can do is plus equals 10. Okay, so we're going to increment revolutions done by 10, and we can just multiply by 2. So looking at this, when it counts to 1 second, we should get revolutions done is 10 beforehand, times 20. RPM should be 200. The next second, revolutions done is going to be 20, right? So times 20, 400. And this is just to clear the flag that goes off when TCNT1 compares true. Compares true. Awesome. So what we can do is we can test it right away. I'm going to play the code. Okay. Turn it on the register. Forgot to turn on the thing. Okay, there we go. So it's incrementing by 800, 1,000. Every 1 second, 1 Mississippi, 1 Mississippi, 1 Mississippi, 2 Mississippi. Yeah, so it's roughly 1 second every 200. And yeah, so that's the timer 1 works for counting to 1 second. Yeah, and this interrupt works.